Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Good morning, afternoon, or evening, depending on where you are, and thank you for joining us once again here in Liberty, South Carolina. This month we're going to do a little something different that we hope you will enjoy. As Lindsay reminded me, thank you Lindsay, I've been in the fire sprinkler business for over 42 years, and I know it was well over 30 years before I actually saw a sprinkler flow water. Now, while we would love to bring one of our 4 demo trailers to your location and demonstrate in person, and please feel free to contact us about setting that up, today we're going to do the next best thing. After a short intro by one of our technical services managers into their respective sprinkler category, along with some tips on what to look for, we're going to take a look at some sprinkler flow videos taken here in our state-of-the-art flow lab in Liberty. This is our main R&D and manufacturing facility, Liberty, South Carolina. Each of the videos is going to run for approximately 20 seconds, and you're welcome to throw questions or comments into the Q&A as we move along. Before we get started, though, let's learn a little about the process of sprinkler development from an engineering standpoint.
Good afternoon. I'm John Corcoran. I'm here with Paul Sasser, here to talk sprinkler development. So right off the bat, Paul, could you introduce us and tell us how long you've been at Reliable and what you did when you first started here?
Sure. My name is Paul Sasser. I'm the Vice President of Engineering for Reliable. I've been with the company a little over 25 years. My first job here was a quality control supervisor. And basically that's a job where you're on the production floor and you're validating and measuring parts all day, looking at processes, anything that might go awry or out of spec, you try to fix and keep the place running. And it was a great, I was there for 2 years. It was a great learning experience for me. I came into the company, didn't know anything about the products we make, brand new to the industry, and it was kind of a baptism by fire. And I learned all about everything we do.
So the heart of any sprinkler, as I see it, is the deflector. So when you're creating a new sprinkler, how do you even start designing a deflector? And would you call that art or science?
I think it's a mixture of both. There aren't a set of advanced equations somewhere that tell you where water's going to go once it hits a piece of metal, right? But we don't have to start from scratch with everything. We have hundreds of prototypes we developed over the years, and we have them all. So if you have a certain water pattern you want to put somewhere, we have a lot of starting points. And hopefully, what you're looking for is close. Sometimes it's exact. Sometimes you don't have to do anything. Not all the time. And other times you have to really sculpt and move metal and do things. And that's where our experience comes in. We have some really talented engineers that can look at the way the water's flowing and figure if they want to put water a foot over, I just have to do that, or some little tweak. And that's the art.
So you've been here for a while, and you've been in this role for a while. How has technology affected what you and your team do, and say over the last 10 years, and where do you see technology taking this company?
Yeah, we do a lot more virtual study before we cut metal. It used to be there was always an inherent risk of getting a part made if you had to invest in tooling, especially casting equipment or stamping dies, before you knew it would work. At least now, we have the ability to simulate, stress, strain, deformation. We have multi-physics software. We can figure out vibration, all these things. We can figure out pressure, computational fluid dynamics, fluid flow. So we're really close to getting the part very high functioning before we cut metal. Yeah, technology is great. We've been 3D printing ever since that came out, and now we're able to 3D print in metal. So we can get a part from a computer software workstation, and in a day or so have a metal part to go out and actually test.
So when you're approaching the labs with a brand new concept, how do you even begin to set up a testing program?
Well, before that's a really good question. So typically our new product ideas come from some new method in the construction industry. Somebody's got a new way to build a building or something different. We'll develop ahead, do some prototype work, make sure the water flow and the ability to put out fires there. And then once we're confident that we have something, we approach the labs and say, hey, what do you think about this? And if they're receptive, they'll take you on and say, okay, I'll give it a shot. And they try to relate whatever they're going to test your new product on back to what they're comfortable with. They have a really good feeling of, what they want to see. And maybe the tests they've normally run are slightly different for your new product, but in general, they're getting the same good feeling about it. That's their goal. And a lot of times they're very receptive to doing it.
So when you think about all the projects that you've managed in your current position, is there one that stands out of which you're most proud?
Wow, not necessarily one. I'm proud of all of them. All of them, to me, I have pretty good memory with these, and all of them had their struggles. When I look at this wall, I'm impressed by all of it. It's so far it's been the last 2 decades of my life, my work, just seeing it all build up, and when you see it all together, it's like, wow, that's a lot. So I'm proud of all the things we've worked on. I have a staff that's top notch, and everybody is really dedicated and supportive. We don't have egos. A lot of engineers want to get their way with a certain design. We all are ego free, and the best idea wins, and that's how we operate.
So how do you feel when you walk into a building and you see a product on the ceiling that was your baby?
Yeah, I've walked into several hotel rooms with my family, and I'll say to my kids, hey, see that? I worked on that before you were born. And whether they appreciate it or not, I'm not sure. But yeah, I enjoy it. I've seen the things I've worked on personally in many hotels and other places. I feel kind of like that's the good I've done in the world, right? And that's the good Reliable's done. Yeah, it's great.
So somewhere in there, I heard Paul use the term sculpt, and really what an apt description that really is when it comes to sprinkler design. It really is a blend of science and artistry, and I think a couple other words Paul may have forgotten in there: magic and luck, as I'm sure Paul would agree. We're going to see that sculpting in action, particularly with some of the special sprinklers, but it's really been happening since the first fire sprinklers back in the late 1800s. So to start with, let's take a look at the evolution of sprinklers from their beginnings over 100 years ago, and particularly at a change that occurred in the mid-1950s. Here to talk about standard sprinklers is a guy I've known for over 30 years, our tech service manager who calls Sioux Falls, South Dakota home, Mr. Scott Hansen. Call sign, get her done. Scott?
All right, thanks, Kerry, and thanks for assigning the old guy to the old sprinklers here. So I'm going to discuss actually 3 different sprinklers. You can see those 3 on the screen right now. If you would, yeah, there you go. Thank you, Lindsay. And starting from left to right, we're going to talk about a conventional sprinkler, or more commonly in today's world, we call them an old style sprinkler. And then in the center, we've got an extended coverage pendant spray sprinkler. And then on the far right-hand side, I've got a standard spray pendant sprinkler. And when you look at these 3 sprinklers and compare them, and we're going to talk about them individually, but they're all similar in shape and common things like threads, frames, thermal elements. What really separates the 3 different types of sprinklers on the screen right now is the deflector design, and Paul kind of touched on that. Paul, when he was talking in his little video there. The extended coverage sprinkler in the center physically is larger, all right, and that's just because it's a 11.2 K factor sprinkler with 3/4 inch threads, so it's just physically going to be bigger. When you look at the old style on the left-hand side and the standard spray on the right-hand side, when you look at those 2, they're both 5.6 K factor sprinklers, half-inch NPT threads. Same frame, same releasing mechanism. The only thing physically different between those 2 sprinklers literally is the deflector. So let's take a look going on to the next slide, and we'll look at the differences in all of the different types of sprinklers. So when we look at the conventional old style sprinklers, okay, you look at them, and I got to get that changed. Carrie kind of touched on this in the mid 50s, and there's actually, like, depending on what you read, 1953, somewhere in that area, where the change came. So the old style sprinklers went out, and the new style sprays type sprinklers came into play. And actually, when you look at the NFPA standards now, and FPA 13 doesn't actually allow new installations to use old style sprinklers. There are exceptions to that rule. And there are exceptions in what one of my counterparts in Europe said they use over there for legacy type designs. But looking at the deflector, all right, so you look at the deflector, it's got a really unique design. And this design allows the water spraying out of the sprinkler, discharging out of the sprinkler, to distribute about 60% of the water down and 40% of the water up. Because of this unique design, they could be installed in an upright or a pendant position. And to do this, the deflector had some unique characteristics. So it's got wider openings, so it allows more water to pass through the deflector, whether the sprinkler was installed in an upright or pendant position. And then the other unique thing on this deflector, you'll see it's got a bend in it. Okay, so it looks kind of like a modified upright deflector. But that bend isn't right on the edge to direct water down all the way. It's more so in the center part of the deflector, and it breaks the water up better. So discharging water makes droplets, and downward discharging water, upward and downward, both make different types of droplets. So when you look in the picture, there's two spray patterns. So I'm talking about the picture in the center between the sprinklers there. You'll see an umbrella shaped pattern in the black lines that are smooth, kind of flowing down towards the floor. And then the second pattern, you're going to see where it's blue shaded, and that's the water directing up towards the ceiling. But what they would found with this, they worked really good if you had a fire right underneath the sprinkler, but not so good maybe, depending on what you're protecting, on the outer reaches of that spray pattern, because that water that hits the ceiling doesn't have the same coverage area, so you would get water deflecting off the ceiling, bouncing back down towards the floor. So you got an area of heavy density and then an outer area of a lighter density. So kind of a designed inconsistency. So let's watch the sprinkler video on that. When we play this video, pay attention to a couple things. The spray pattern is not uniform, and you'll see that, especially when you look at the center right below the sprinkler and the outer coverage areas. And then notice, once again, because we're directing water up, how much water is hitting the ceiling. Just another note, when you've got old style sprinklers that you come across in the field, they use the same type of coverage areas that standard spray sprinklers do. So if you're going to replace old style sprinklers, you use a regular upright or a pendant. You just have to use the appropriate upright or a pendant type sprinkler. So go ahead and play that video if you would. All right. So hopefully you guys got to see the differences in that, or got to see the uniqueness of that spray pattern. Let's move on, and we'll talk about standard spray pendants and uprights. So like I said in the previous slide, they took the place of conventional sprinklers for most applications in the early 50s. And what's unique about the standard spray sprinklers is they're designed to direct 100% of the water discharging from the sprinkler down towards the floor. A huge move away from the old style technology. And the reason for the change is the research proved that directing all the water down towards the floor provided better fire protection. Since the water is directed all down towards the floor now, whether it's an upright or pendant, orientation does matter. Whereas the old styles, you could use it as an upright or a pendant. You have to use an upright or a pendant. And if you look at the spray pattern in the center here, you're going to see the water is kind of discharging down. So you get that umbrella shaped pattern. And then looking at the pendant on the right-hand side, you'll notice a very flat deflector design. You look at the upright on the left-hand side, and you're going to see that, it's got a unique design. It's curved, it's got a downward shape, so that umbrella shaped pattern. And it does a very good job of basically deflecting the water, either whether it's upright or pendant, and spreading it out to get its coverage areas that it's being utilized for, and developing a nice uniform pattern with even droplets. They're density area sprinklers now, so the flow and pressure is determined by the area, the density, and the K factor of the sprinkler. So when we look at these videos for the upright and the pendant, you're going to see the upright on the left-hand side, the pendant on the pendant on the right-hand side, the upright on the left-hand side. And you're going to notice, you should notice the even distribution over the coverage areas. Now you're going to see some, but very little water is going to hit the ceiling with either of these types of sprinklers. And if you look at the curtain on the left-hand side, you're going to see more water hitting that curtain now, just because we've got more water being distributed evenly throughout the whole coverage area. And then just another side note, when you look at that standard spray upright on the left-hand side, you're going to see that vertical pipe that's pretty close to it, but it is in compliance with the 3 times rule in NFPA 13. But you're going to see water, a steady stream of water running off the backside, which is showing you that, or proving basically that water's wrapping around that whole pipe and hitting it and getting coverage on both sides of the pipe. So if you want to go ahead and play the video for the standard sprays. All right, extended coverage sprinklers, and this is going to be the last one I'm going to do for you today. But extended coverage sprinklers are just another type of a spray sprinkler, and really what that ends up meaning is that they, just like standard sprays, they direct 100% of the water discharging from the sprinkler either up or upwards and deflect it down as in an upright or pendant sprinkler. Okay, so orientation matters here as well. So extended coverage sprinklers typically, but not always, have a different deflector design when compared to a standard spray sprinkler. Usually a little bit larger in diameter, and maybe has a unique feature here or there where something got tweaked, or a little bit of luck played into the design here. So what you're going to notice, and you can kind of see it in that center picture here between the 2 sprinklers, is that the spray pattern developed is much flatter than the traditional umbrella shape you saw in the standard sprays, simply because we're covering a larger area and we need to throw the water farther out from the sprinkler. They're still density area sprinklers, but because they have a unique spray pattern, and you'll see that in when the other guys start presenting, so the required flow and pressure are determined by the testing during the listing process of that sprinkler. So when we watch this video, some unique things, you're only going to see one sprinkler flowing, and it's going to be in the center of the room. But once again, you're going to see that even distribution over the coverage area, and you're going to see some, but once again, very little water hitting the ceiling directly above the sprinkler. But you're going to see a much wider coverage area. So that single sprinkler is in the center of the room, and the spray pattern is actually hitting the side curtains on both sides of it. And those curtains, just an FYI, are 27 feet apart. So if you start thinking about this extended coverage sprinkler has a 20 by 20 maximum coverage area, and it's literally a square pattern that we're fitting into a round circle. So that circle has to be bigger than that 20 by 20 coverage area. And I'm a math nerd, so just doing the math, that means the diameter of the circle has to be 28 foot 4 inches at a minimum. So go ahead and play the video here if you would, please.
Thank you, Scott. Just a couple of notes. We got some reports in that the first video froze. That's likely to happen due to bandwidth and things like that. So just a reminder that this will be recorded and will be available for later viewing, and you shouldn't have any of those issues. One of the things to notice as Scott went through his presentation there, particularly with the standard spray sprinklers, was that very, very even distribution of water onto the floor that necessarily you didn't get with the conventional sprinklers. And then if you notice on the last video, the extended coverage video, it almost looked like there was a hollow spot in the center of the pattern right below the sprinkler. And people would look at that and go, wow, that's not going to really take care of putting out the fire. So let's make sure we distinguish between extinguishment and control, right? So if you have a fire directly under that sprinkler, it cannot escape the ring of water that is surrounding it. And that's paramount to actually controlling that fire as opposed to extinguishing it, which we have to get water directly onto the flames. So next up is residential sprinklers. Residential sprinklers save lives. There are no ifs, ands, or buts about it. They excel at the job they do, not because they discharge huge amounts of water, but in fact just the opposite. Residential sprinklers do a lot with a little, low flows and low pressures. So next up on the list here to discuss residential sprinklers is another guy I've known for a few years as well, not just because he's my wife's brother, but also because he's just a great sprinkler guy. So helping us out today with residential sprinklers, hailing from Portland, Oregon, is Tech Service Manager Dave Thompson, call sign Babyface. Dave?
Well, good morning from the Great Northwest, everybody. As Carrie indicated, my name is Dave Thompson, and I'll be introducing unique characteristics of the residential fire sprinklers. Residential fire sprinklers began development in the early 1970s, with a new class for residential fire sprinklers beginning in the 1980 edition of NFPA 13. They've only become more specialized since, with specific coverages, flows, and pressures. When compared with commercial type sprinklers, residential fire sprinklers are designed to throw a high, wide, flat fan shape as opposed to a downward cone or downward arc that we just watched in the last few videos. Note that the water droplets were much larger with the commercial style fire sprinklers than we will see with the residential fire sprinklers. Residential fire sprinklers have a quick response thermal element. They come with a wide variety of K factors and coverage areas, but are available only in pendant and sidewall applications. NFPA, as well as UL and FM requirements, specify the need to meet a 28-inch wall wetting pattern on the vertical surface of all walls within the protected space. In the upcoming videos, you will see this in action with significant water flow high up on the wall surface. Additionally, residential fire sprinklers need to control a fire in the room of origin for a 10-minute duration to allow for people to escape. Next slide, please. Fire sprinkler deflectors with high wall wetting and flat discharge patterns improve survivability during escape from a fire event. These deflector characteristics produce small water droplets, forming more of a mist than a rain shower. And this saturating high flat pattern cools the ambient temperature and drives soot and toxic gases from collecting at the ceiling and down towards the floor. The graph on this slide represents a cross-section of a 20-foot by 20-foot room with a pendant residential fire sprinkler in the middle of the ceiling. The upper right-hand corner of the graph indicates that the wall wetting pattern is within 12 inches of the wall and ceiling intersection, and thus meeting the requirement 28 inches from the ceiling. Next slide, please. As indicated earlier, residential fire sprinklers were developed with specific criteria for flows and pressures. Note that there are different densities required for NFPA 13D or 13R as opposed to a typical NFPA 13 installation. Next slide, please. There are 3 residential fire sprinklers we'll be highlighting today. The first video we're about to see is the RFS42, shown here in the upper right of the slide. The compact deflector and thermal element allow the fire sprinkler to be installed within a wall cavity. After the discussion is released and the thermal link is activated by heat, water pressure forces the collapsed diffuser to extend horizontally on integral pins. It would be located on the vertical surface of a wall within the protected space. Like all residential fire sprinklers, the video will show significant water flow at all wall surfaces up high and within 28 inches of the ceiling, including the wall on which it is mounted. The second video will show the spray pattern of our RFC49, a pendant style fire sprinkler, which is mounted at the ceiling in the protected space. Typical to all residential fire sprinklers, it has a quick response thermal element, and it has a mist type spray discharging to cooler room and to drive gases to the floor. The photo in the upper left is the reliable F1 HSWX. It is a horizontal sidewall fire sprinkler, and it would be located on the vertical surface of a wall within a protected space. As an extended coverage type fire sprinkler, it has the ability to throw the required density to a distance of 26 feet. It will be the third and last of the residential videos to be shown next. Thank you for your time. Please start the video number 1.
Thank you, Dave. Just for point of clarification, so that we don't, that we do our due diligence here. Dave mentioned residential sprinklers being pendant and sidewall only. There is in fact a manufacturer who does make an upright residential sprinkler, so you can feel free to go out and find them as well. The wall that was to the left in all 3 of those videos was 16 feet from the adjacent wall. The first 2 videos showed that pretty clearly, but what was interesting in the very last video was the projection well beyond the 16-foot mark of that residential HSW 58X. So the next category that we're going to talk about is no doubt the most fun, but at the same time probably the most challenging. Special sprinklers, by definition, often make their own rules, and this can wreak havoc in a rule-driven industry such as fire sprinklers. So as you watch this section and watch the videos, remember the term we used, sculpting, in the opening portion. Joining us from New Hope, Pennsylvania, and one of our newer members of the Reliable Tech Services team, please welcome Sam Schwander.
Thanks, Gary. All right, so I'm going to be highlighting some special sprinklers for everyone today. And let's start by defining what exactly a special sprinkler is and what really differentiates it from the rest. So NFPA 13 defines special sprinklers as sprinklers intended for the protection of specific hazards or construction features. So these special sprinklers need to be evaluated and listed for their performance under very specific conditions. And that requires performing fire testing to establish criteria relating to the specific hazard, the thermal sensitivity of the operating element, the spray pattern distribution with respect to wetting of the walls and floors, as well as with respect to obstructions, criteria related to water droplet size, and performance of the sprinkler under horizontal or sloped ceilings. So this often results in sprinklers that have very unique characteristics, such as the deflector design itself. So the special sprinklers we're going to be highlighting today include sprinklers for combustible concealed spaces, attics, and corridors. Now there are other examples of special sprinklers, such as sprinklers for MRI rooms, metal buildings, and window sprinklers, just to name a few. But our first special sprinkler today that I'll be talking about is sprinklers for combustible concealed spaces. So these are UL listed special application sprinklers, as I said, for combustible concealed spaces, referred to as combustible concealed space sprinklers. So I'll be referring to them as CCS sprinklers moving forward. On the screen on the left-hand side, that's the reliable model KFR CCS. And this is an upright sprinkler, and you can see how the deflector is much flatter and larger as compared to, say, a standard spray upright sprinkler. Now, these CCS sprinklers create a much flatter spray pattern and discharge the water more horizontally, and that allows superior water distribution in a shallow space relative to that of a standard spray sprinkler. Another aspect to the CCS sprinklers is the smaller water droplet sizes that they produce, and that helps cool the concealed space. So these characteristics are really designed in order to achieve the main goal of preventing the horizontal propagation of fire within a concealed space. Lindsay, if you could go to the next slide, please. So here we're looking at standard spray upright sprinklers in a combustible concealed space. As Scott explained earlier, these sprinklers provide that umbrella-like spray pattern, and this pattern takes some vertical distance to develop, and that leaves us with unprotected gaps within these shallow spaces. So with CCS sprinklers, the horizontal water distribution is going to fill these gaps, and in many cases, it will allow us to space the sprinklers further apart to achieve greater coverage. So when we go over to the flow lab, you're going to notice how the spray pattern is throwing water upwards and outwards, and again, that allows the water to be distributed in those shallow spaces that are provided in most combustible concealed spaces. And you'll also notice how the water droplets are smaller compared to that of, say, standard spray or even extended coverage sprinklers. All right, so next we have the DS56, where DS stands for direction singular, which is a UL listed special application sprinkler for attic protection. So this particular sprinkler is designed to be installed at the peak of a 4-12 to 8-12 roof and spray down to the eave in a single direction with 6-foot maximum spacing at the peak. So the DS56 in particular is required to be installed 30 inches to 42 inches from the back wall or from the draft curtain when back-to-back installation is incorporated. So as illustrated by this isometric drawing on the screen, the deflector is designed to also discharge behind the sprinkler, which covers that 30 to 42 inch space behind where the sprinkler is installed. But you'll really notice the prominent design of this sprinkler's deflector and how it arches outward. So the result is a sprinkler that produces a spray pattern that can achieve up to a 40-foot span in a single direction from the peak of a roof to the eave. And we're really going to see that highlighted now over in the flow lab. All right, and our third special sprinkler today is the LT56 series, and these are UL listed special application pendant sprinklers, and they're specifically designed for long, narrow spaces such as corridors or hallways. So the deflector design for these sprinklers are long and narrow, and it provides a maximum allowable spacing of 28 feet long by 10 foot wide. So this 28-foot long dimension exceeds the maximum allowed 20-foot spacing for extended coverage pendants in NFPA 13. And similarly, this sprinkler has a 14-foot minimum spacing required in the long dimension, and that's greater than the 8-foot minimum required by NFPA 13 for extended coverage pendants. So this type of sprinkler provides a hydraulic benefit compared to traditional standard spray and even extended coverage sprinklers when utilized in corridor designs. Because when calculating a single line of extended coverage sprinklers per NFPA 13, the most demanding 75 linear feet of corridor must be calculated. So by taking advantage of this 28-foot spacing, as little as 3 LT56 sprinklers may be calculated, resulting in fewer sprinklers and less water demand. So when we go over to the flow lab, we're going to be flowing the LT56C sprinkler, which is the concealed model, and we'll be viewing it from the side profile to really highlight that long 28-foot spacing. So you'll notice just how far that sprinkler is capable of throwing water in either direction.
So Alan Larson, who's coming up next, reminded me that I didn't give Sam his call sign this morning. I did that intentionally, or didn't do it intentionally. I didn't want to throw him too much off his game. But we're toying with the idea of either call sign Scarecrow or call sign Slender Man. We haven't settled on that one just yet. So a couple things about what Sam was discussing there. With particular regard to the CCS sprinkler, we talked about this a little bit with residential, that misting and cooling effect that takes place off of sprinklers like this. We're not looking for direct impingement. Remember, we're in spaces with gang nail trusses, a lot of vertical, horizontal, diagonal obstructions, and trying to get water to actually impinge on every surface is an impossibility. So the misting and cooling effect, very important in situations like that. I mentioned the rules regarding special sprinklers. UL, who's the primary approval agency for special sprinklers like this, sets up a prescriptive test program that all the manufacturers must comply to. It cannot cover, and it does not cover, every possible configuration of attics and blind spaces and things like that. So consequently, when we see designs that don't match the prescriptive test, we often get questions into tech services. I'm sure the other manufacturers do as well. What do we do in this particular instance? And oftentimes we'll apply the spirit of the listing as a matter of fact, and oftentimes we can just look at it and maybe make some suggestions about how to go about actually protecting a space, and oftentimes, quite honestly, we need to get the AHJ involved in that as well. Finally, with regard to the DS56 sprinkler and attic sprinklers in general, if you noticed in that particular video, there was a huge amount of water that was running down the upper surface of the deck. And that's very important to get that wood surface, typically is a wood surface, wetted and allow that water to run down toward the eaves. So very important part of the design of those attic sprinklers. So moving on with storage. So with some limitations, depending on the design density, the standard spray sprinklers that Scott showed us in his category can be used for storage occupancy. There was a period in Washington State where I worked where the Washington Surveying and Rating Bureau required an odd density, we always thought, but it was a 0.39 over 5,600 for spec warehouses. And back in the day, in the late 70s, early 80s, we often struggled to make the hydraulic calcs work with those great big 8.0 K sprinklers that we had at the time. So remember, for each jump of 5.6 K factor, there's a 100% increase in water discharge. So currently in the industry, we now have fire sprinklers with K factors all the way out to 33.6, which means it discharges 6 times the water of a 5.6 K sprinkler at the same pressure. So in a real life scenario operating at 55 PSI for 50 feet of storage, these monsters are discharging 250 gallons per minute. So I like to use the analogy of filling 5 55-gallon barrels almost to the top in 1 minute from one sprinkler. So here to talk a bit more about storage sprinklers, currently calls Easley, South Carolina, his home, Tech Service Manager Alan Larson, call sign Chili Dip.
Thank you, Carrie. I was waiting to see what that was going to be. So appreciate everybody being out there and hanging with us. So if you are a person who's watching this webinar, obviously you are a sprinkler nerd like the rest of us. So let's jump into our storage sprinklers here. So when we talk about storage sprinklers, there really are three different designations, right? And the first one is CMDA. And if you've seen or listened to some of my webinar presentations before, you know that I'm an advocate that our industry loves acronyms. So here we've got three more for you. So CMDA, Control Mode Density Area. And with a few exceptions, and we've actually highlighted a couple of those exceptions today, most of the sprinklers that you work with and most of the sprinklers that you design around are control mode density area sprinklers. If you look into the design standard and the design standard gives you a density over an area, you typically are utilizing a control mode density area sprinkler. Okay, almost all sprinklers are control mode. The second type that we use in storage are called control mode specific application. Well, what does that mean? Well, that basically means that the manufacturer has taken a control mode density area sprinkler, taken it to the lab, and tested it to some degree beyond its normal capability. Whether we've tested it to achieve an extended coverage over what would typically be acceptable, whether we have tested it to achieve a different, and in many cases, smaller density than would normally be acceptable. But we've taken it and gotten, again, a specific listing for a very specific criteria with that particular sprinkler. And then the third type are early suppression fast response, ESFR sprinklers. And you note that, you know, we now have taken the word control out of our acronym and we have put the word suppression in. These are sprinklers that are truly designed to suppress a very high challenge fire, usually from a very high height in a storage occupancy. We'll show you how we do that when we get to the live video in the flow lab. But basically, it is very large drops and a very, very good main core of water designed to penetrate a fire plume. So to confuse things just a little bit more before we move to the next slide, if you design in the FM global standards, they have their own designations, and all of the sprinklers that we're going to talk about today, if you're looking in the FM global data sheets, are considered quick response storage sprinklers for FM. So Lindsay, if we can flip the slide. So the first sprinkler we're going to talk about today is the model GL112, and in our nomenclature, what that really means is that is a G frame. That's what we call that. L means that it is a link. It is a soldered fusible link, not a glass bulb. And 112 simply means that this is an 11.2 K factor sprinkler. So it's a CMDA, control mode density area sprinkler. When we first developed this sprinkler, we developed it to be an FM approved quick response in-rack sprinkler. That's exactly what it was designed to be. However, it also has listings to be used in ceiling only applications. So this sprinkler can be used in storage, it can be used in non-storage, it can be used in rack, and as you see, we have different guard and shield combinations, both for the upright and the pendant, that can be applied. So it's an extremely versatile sprinkler. So when we look at it, what you're going to see when we look at the flow is that you're going to see the umbrella pattern very much like you saw in some of the opening videos with the standard spray upright and pendant sprinklers. But you're going to note that you've got a much larger droplet size, and again, very consistent with protecting a higher challenge fire. So Lindsay, if we can see that video, please. You really can look at that and see that you've got, you know, very, very large droplet size, and you really do get a really good indication of that, you know, quote unquote umbrella pattern that we talk about. And you know, specifically in the installation standards, the design standards, you know, there are criteria about exactly what that pattern needs to look like. And you know, if you listen to Paul's interview with John at the beginning, you know, that's what our engineers down at the other end of the building are doing. They have a lot of parameters that they need to design into, and so this is, you know, this is the end result of all of their work. So,
Hey, Alan,
sure.
just want to throw a quick comment in there while we're looking at this. That width across the bottom of that discharge from wall to wall in that flow lab is about 27 feet. Excuse me. So think about the fact that that's a standard protection coverage area. Pardon, GL112, right? So that sprinkler is going to be spaced, you know, in the neighborhood probably for use like that in the 100 maybe 130 square foot area. But imagine the spray pattern across the bottom being at least 25 feet wide, and that just kind of brings home a point which we really haven't discussed, which is the fact that all fire sprinklers, when they're side by side like that, overlap. And so that gives us the more even coverage area down on the floor. Back to you, Alan.
Thank you, sir. So yeah, Lindsay, if we can jump to the next slide, please. So the next sprinkler that we're going to talk about is model N252EC, and again, following in that nomenclature, N-frame 25.2 K factor, extended coverage. This probably is, in my opinion, the most versatile sprinkler that Reliable has in its lineups. This sprinkler is listed as a control mode density area sprinkler, extended coverage, as it says, it mentions there, all the way up to 196 square feet, so that's 14 by 14 spacing. Again, quick response, extended coverage, extra hazard as a CMDA sprinkler. And then also, as I noted, we take the sprinkler and we go get specific application listings. So this sprinkler also has specific application listings as an extended coverage storage sprinkler. So it does that, and then it also operates as an in-rack sprinkler in what we call the NRAC EC system. So in that vein, the picture that you see on the right there, we do have guards. This is a pendant only. The 252 EC is a pendant only sprinkler. We do have guards for that sprinkler. The guards are only listed when you utilize the 252 EC as an in-rack sprinkler. So this sprinkler is FM approved, FM Global approved as a quick response storage sprinkler. It is UL listed. The UL listing, the testing protocol is a little bit different. If you utilize it as the UL listed sprinkler, which you might be, the picture on the left with the white polyester and the two-piece recess discussion, in the UL listings, it is a standard response sprinkler, not a quick response sprinkler. Again, a little bit of an anomaly in the testing there. So let's and again, when we look at the spray pattern, we look at the flow. What you're going to notice is different is it's going to be much more like the extended coverage sprinklers that Scott showed you flowing earlier. Although, and as Carrie just noted, because we've got a much bigger bore, we are going to have a lot more flow, we're going to have a lot more water, and we are going to develop a very, very large pattern with very big drops. So Lindsay, if we can see the flow of the 252, please. Oh, sorry, I have to back up. We got one more slide here. So a little bit of foreshadowing. So, and again, this is a little bit like Scott mentioned earlier. If we look at two different K25 sprinklers, we have the 252 EC deflector on the left, and we have the N25 ESFR deflector on the right. Same frame, same fusible element, pretty much brothers in terms of sprinklers, but very, very different in the way that they distribute water. You note that the 252 EC deflector on the left, there's a lot more metal there, and what that does is when the discharge impacts that, It's going to spread that pattern out and create that extended coverage pattern that we're looking for. Conversely, the ESFR deflector on the right, many more openings. What we're trying to do with that sprinkler is we're trying to direct much more water straight down, again, get big drops and a big center core of water down into the fire plume and try to suppress that fire. So got a little out of order in my mind there. So so now, Lindsay, please, if we can look at the N252 flow. So again, as Carrie mentioned, we're looking at 27 feet there, curtain to curtain. This is a sprinkler, again, that in pretty much all of its different applications at the ceiling is going to be listed for coverage areas up to 14 by 14, 196 square feet. You do get a very good indication if you look right up at the sprinkler itself of how flat that water distribution is coming off the deflector. You can really get in the lights, both right and left, get a very, very good indication of really how large the droplet size is with that sprinkler. And if you look on the floor down by the trench drain, just take a good look at literally how much water is on the floor coming from that sprinkler. It is it's a great amount of water, and you know, math is math. And as Carrie mentioned, when you've got an orifice of that size, K factor 25.2, you do not have to apply much pressure to it to get a very, very significant amount of water out of that sprinkler. But the benefit, the beauty of this sprinkler as a storage sprinkler with its extended coverage spacing is that you are able to utilize a little bit less of them, able to save branch lines, able to save some flow, even though you're using a large bore K factor sprinkler. So, all right, Lindsay, if you jump to the next one, please. So the last sprinkler that we're going to talk about today is that model N25 ESFR sprinkler. You just saw the deflector a second ago, and obviously the idea here is very, very high buildings, eliminate in-rack sprinklers. Again, give that strong center core and those large drops directly down to really suppress a very, very high challenge fire. So this is going to be a 1-inch NPT threaded, or also available with an IGS groove connection. If you design the sprinkler, buy the sprinkler, install the sprinkler that way, you know, when you receive the sprinkler, it is going to come with the coupling. It's not a part that you need to order separately, and mate that to a grooved outlet, and hopefully really you know, speed up your installation process. Again, these sprinklers are pendant only, early suppression, fast response, 25.2 K factor sprinklers. And Carrie also noted, you know, again at 55 psi, you are developing a major amount of flow. You're going to be limited, obviously, in that instance to 100 square feet, and you are going to be flowing a lot of water. So obviously the idea here, eliminate the in-rack sprinkler. So now let's look at the flow from the N25 ESFR. With that, I think we'll throw it back to Carrie.
Okay, thanks again, everyone, for sticking with us here. We're just about wrapped up. So we had a question kind of come up with regard to the guard that Alan showed on the N252 EC, and whether or not those guards affect the distribution pattern. And the answer is yes, but the kind of the fun part of the answer is sometimes it's in a good way. So oftentimes we find a little bit more even distribution because of that. But the reality of that guard, and all guards for that matter, is that they are tested at UL and or FM for that very reason, and for that reason they must be listed with the fire sprinkler. So unlisted guards with fire sprinklers, not good. So again, I just want to say thanks to all my guys out there for their help and for being a good sport today. They didn't know they were going to get nicknames. Don't know whether or not the monikers will stick, but I know we had a little fun with it. As far as I know, John, we have one question in the queue. Is that correct? Yeah, so specifically for the residential fire sprinklers, we did run all three of those at the same pressure. So as you go back and watch those, just keep that in mind. And like all fire sprinklers, they're designed to discharge at a minimum pressure of 7, or operate, I should say. Now, their discharge operating pressures are going to be listed in the bulletins. They may be higher than that, and likely will for the extended coverage areas. But again, the pattern must develop and the wall wetting must occur at those minimum flows and pressures that are listed in there. So I think, and as far as the other videos go, we did manipulate the pressures a little bit to kind of mimic as close as possible to what we would see out there in the real world. So again, as you go back and watch those, keep that in mind as well. So if you've been with us for the past year, and as we've reminded you a couple times today, each reliable webinar is recorded for later viewing. Those will be put up when they're available. As a special bonus this month, in addition to the videos that we saw today, we're going to throw some other ones up there. And if you have a particular reliable fire sprinkler that you would like to see flowed, let us know. It's not a lot of work to get out there and set it up, and we could get that one up there as well. So I want to make a quick shout out to a couple people, Victoria at SFPE, Jeff at Commonwealth Sprinkler, Mike at Cogswell, Bobby at Chattanooga Fire Protection, and our friend Cecil Bilbo, the self-proclaimed premier sprinkler geek at the Academy of Fire Sprinkler Technology, for their suggestions for this event. We hope you enjoyed your time here with us today, and we look forward to seeing you at our next webinar.